All right, so what can we do with this here? A couple things. First thing is we could just apply the sine inverse. So x equals the arc sine, negative 0.77, which is the same thing as saying x equals the sine inverse of negative 0.77. I prefer arc sine, but sine inverse means the same thing. What is that going to give me? So think about the unit circle for a minute. Whoa, let's try it again. It's a little better. On the unit circle, the sign is a y value. So if this is -1 there, that's 1 for y. Negative 0.77 is going to be around right there. That y value leads to this point over here, or that point over there. And so angle-wise, that's this radius there, or this radius here. How shall we measure those angles? So the easiest way to measure the red angle would just be to head in that direction like that. The blue angle, I have two ways. The closest one to the x-axis here would be that one, but I could go around this way to get there too. So I have a couple of ways to work on that. So let's undo that for a second. Which one is the sine inverse going to give us? Okay, so then I have to think about what's the range of the sine inverse. And remember, it has a range from negative pi over 2 to pi over 2. So that range right there is this right semicircle over here. So it's going to give me the red angle. Then I got to figure out how to turn that into the blue angle over here. So this red angle theta is equal to the sine inverse of negative 0.77. Now this blue angle right here has a reference angle right there, which due to the symmetry of the circle is that angle theta right there. Now this angle theta is negative. If you don't believe me, plug it into a calculator, right? It's negative because I went that way to get it. And the sine inverse knows about negative angles from 0 to 90 degrees or 0 to negative pi over 2. So if I take pi, so pi would get me to here, and then I add on the positive version of this angle, then that's going to put me right here. So that would be one way to get it. Other way I could think about it is if I went negative pi, and then I took the positive version of that angle to back up, that would put me here too. So I'm going to go with my first version. I'm going to take pi, and I want to add the positive version of that angle. Now I know that angle is negative, so my claim is that the other solution, let's call that x2. Let's maybe make that blue, is going to be pi minus the sine inverse or arc sine. Let's use sine inverse this time, of negative 0.77. So my claim is that those are the two answers. Now I just got to double check to make sure that's true. So let's do some calculations. Come back here and see if they seem reasonable. So I claim the first answer is the sine inverse or arc sine. Sine inverse is available over here of negative 0.77. And I should get a negative radian angle there. So it says it's about negative 0.879 if I went to 3 decimal places. So let's make a note of that. This is approximately negative 0.879. The blue angle, my claim is pi minus that. If I minus a negative, I get a positive, which is that reference angle there, plus pi. So Let's see if that seems reasonable. So I claimed it was pi minus the arcsine, negative 0.77. And so that should give me a radiant angle of 4. So let's 4.020 if I went to 3 decimal places. So let's see if that seems reasonable in my picture. So this one, blue, is approximately 4.020. So if I go around pi radians, pi is about 3.14. And then I go over another 0.879 radians from that, yeah, that should be about 4 radians to get to this angle right here. So again, this right here is approximately theta equals about 4 radians. This angle over here, the red one that I found, that's just under 1 radian in the negative direction. And that seems reasonable looking at my picture too. Last double check is we can graph y equals the sine of x and graph y equals negative 0.77. And so from 0 to 2 pi, I have, let's see now. Ooh, I just lied. What did I do there? I didn't follow directions. This second angle here isn't from 0 to 2 pi. So although it does solve this equation, it's not in the domain I was asked to find here. Okay, so we got to redo that red angle. Let's draw that picture again. Good thing I went back and read the directions. That looks more like a heart than a circle, but we're going to go with it. So again, on the unit circle, sine is a y value. So down here is that y equals negative 0.77. The sine is familiar with angles on this right side there between negative 90 and 90 or negative pi over 2 and pi over 2. So that puts me, so this right there is what the arcsine gives me for negative 0.77. The problem with that, it's a negative angle and I want a positive version of that angle. So how am I going to get that? Well, the way I'm going to get that is say, well, to get there, maybe I'll use green, I'm going to have to swing around in a positive counterclockwise direction to get there. So the way to think about that is if I went all the way back here, that would be 2 pi. And then if I just back up by that angle right there, that should get me there. So the positive version of this same radius there to get to that point should be 2 pi plus the arctan, or arcsine, sorry, arcsine. And remember, this particular arcsine is a negative, right? So that adding the negative is going to back me away from that 2 pi and put me right there. So I think I just found that angle right there. So let's double check that. So my actual x1, let's make that one in green, should be 2 pi plus the arcsine, or sine inverse, of negative 0.77. So this one is a solution to the equation, but it's not in the domain I was asked to look in. Calculator, please. And let's close. Let's see, we can just add it up here. So I want to take that angle and add 2 pi to it. So the angle I want should be about 5.404. 2 pi, remember, is about 6.28. So I believe I have 2 numbers in that region, and I can get the graph to back me up on these. So let's see. So earlier I had found this one right here. There's my negative 0.879 I had found, but that's not in the domain I was asked about. I was asked to find an angle that's out this way. So one of them is the 4.02. We found that earlier. And the one we just found now is 5.404. Okay, Boom, done. That was fun.